Hi everyone, welcome back. Today we are gonna learn about HoughCircles. This function is help us to find the circles inside an image. This is a very powerful function, and but you need to define the parameters very well. Otherwise, it's gonna be a garbage in your case, because the parameters you are defining is the most important part for finding circles. Okay. And let's talk about the parameters. First of all, the input image should be 8-bit single channel image should be. Then it's gonna give you the output in the 32-bit float type, and it's gonna be 3-channel image. The first channel is gonna be including x-axis, then y-axis, and it's gonna give you radius. With these three, you will be able to draw, you will be able to get your circles. The method, there are two methods actually to be able to detect the circles. We are gonna more talk about these two, Hough gradient and Hough gradient alt. In the code part, we are gonna talk more detailedly. DP is, if you don't, I also don't know really this one, but just leave this one. Leaving this parameter 1 is the better one, but in some cases, maybe in Hough gradient alt, you can use DP as 1.5. But the suggested one, just leave it 1. The minimum distance, similar to the good features to track in the previous video we already talked, this is also similar to that. Minimum distance between the centers of the detected circles. This is some kind of filter parameter, we can say. And the first method, specific parameter, this is also about threshold of Kenny, similar to that, because in the background you are giving grayscale input and it's making a transformation. It's gonna make a convolutional operation, so it's most probably using Kenny edge detector, and this is the threshold to that one. If higher these you are using, it's gonna give you the higher accurate circles. If you make it lower, it's gonna give you lower case. Or in other words, this about contrast. If your circles inside an image, if not really clear, it's better to choose this parameter lower, like 100 or 50. But if your image's contrast is higher, like all of the circle edges are very clear to see, then it's better to use this in a higher value. Then parameter 2, this is separated between Hough gradient and Hough gradient alt. For Hough gradient, you can use like from 10 to 1000 even you can use. This is also another accuracy parameter we can say. But in Hough gradient alt is separated from 0 to 1. It's more close to the 1 for this method. It means it's gonna give you the most accurate circles it's gonna give you. If close to the 0, it's not gonna give you really accurate circles for this function. For this parameter, you can use from 10 to 1000 even you can use. They are separated between each other about the scale of the parameter. And this is the minimum circle radius, and this is the maximum circle radius. This is very easy to understand. And all of these parameters, let's see in the code part very detailedly, see how they are working. First of all, I want to use this image. This is a very clear image and I want to detect the circles. Then this is a real world image, like there are some hills, difficult to detect maybe, and also there are this image. I want to detect for all of these input images the circles inside these images. Let's start with the easiest one. The easiest one is this one. Let's run. Okay. This one, the easiest one, and let's detect all of the circles inside. And first of all, I'm converting my input image to the grayscale, which is 1-channel image. Then I'm directly calling my HoughCircles, the input image, the output. Let's define math and circles. This is gonna be my output. Okay, then the method, let's start with Hough gradient, then also DP, as I said, suggested 1. It's better to use 1 always, I think. The minimum distance, let's see the image again, cannot see that. Let's run again. So the minimum distance between pixels I calculate from here, by the way, left and below. Then the minimum distance, let's check. Okay, 300, 100, from here to here, 70 to, okay. We can define the minimum distance between the circles, 50, let's say. 50 pixel is okay. The parameter one, this is, we can start with 300 maybe, because in here we already said contrast, right? In this part, contrast. So in our input images, the contrast is higher. For this image I'm talking about, you see the contrast, these circles contrast is very clear. So it's okay to use a higher value like 300. But what about this? In this image, in the later, we are gonna decrease that value because the circles are not really clear, because this is a real world example. And okay, 300. The parameter 2, if you are using Hough gradient, in here we have already talked, is okay from 10 to 1000. We can give an average value like 100. Then minimum radius is gonna be, let's say 10. The maximum radius, let's say 100. Okay, and done. My function is done. So I'm gonna get at the output of this function circles math format. But as I said, the type of this circles, let's check again as we always did. Okay, dot type, and let's see. You see 21. 21 is representing the CV32 float channel 3. If you don't know about this, you can check the table which I already shared in my math types video. Please check it. I'm already talking about them detailedly in there. And this is type of this math format, these circles. Because it's 3 channel, we have already said. 3 channel representing X, Y and radius. Each channel, 0th channel, 1st channel and 2nd channel is gonna represent respectively X, Y and radius. And after this, okay, this is done. Now we need to represent the circles. How to represent? First of all, make a for loop. Integer I is equal to 0, and the output is circles dot columns. And inside this, I'm gonna draw for each of them. But what about size? Let's learn the size of also. Okay, 21. 21 was the type. 11 column and 1 row is including inside. And here if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Some of them is not able to find. Let's see which one. And maybe we can directly also write how it looks like. Okay, here, yeah. In here, each of 3 is gonna give you each circle. For example, this one. The first one x-axis, y-axis, and this is the radius. The third one always the radius. Here you are gonna see. This is 1 row, you see. This is represent 1 row, and 11 column. It means 11 circle is detected. And let's draw the circles. First of all, to be able to understand integer, even these are double, it's okay, integer just for representing. X value, x-axis, or we can say, is equal to circles dot add. Since 3 channel float type, we are gonna find 3f. Okay, and after this, we can call the point. First of all, column, then the row, since row is gonna be always 0, and the 0, and it's done. Now I'm able to get x-axis, same for y-axis, same for radius, and it's gonna be radius. And this is the first channel, this is the second channel of the image. And now I can draw. We already learned circle drawing. I'm gonna draw in out here to be able to show. Then the center is gonna be my point. This point x-axis and y-axis, and done. Okay, what else? The radius is radius. Then the color, our favorite one, yellow. Then the thickness, let's say 5. I think I'm done. I'm able to draw in out and I'm gonna show. Let's see. Okay, it's able to detect, as in here we said 11 circles. But what about these 3? Why didn't detect? Because I believe the maximum radius we defined 100, let's say 150. Now it's able to detect all of 14 circles inside the image. So basically what we did here, if you decrease this threshold, you are gonna decrease also the accuracy. Let's say if you make it 50, it's not able to detect. But if you really decrease that, okay, this is not about, this is because of contrast, sorry, not this one, but this 100, I am mistaken. If you decrease it, you are gonna get many results like this. Most of them is wrong results because I'm sorry, the parameter 2, it should be this one. If you decrease this one, you are gonna decrease the accuracy. This was about Kenny edge detector threshold, sorry for that. And this one, if you decrease, you are gonna get low accuracy. So it's better to keep it high in some cases. And this is the minimum distance. For example, let's see the image. If you wanna eliminate the smallest one, you can define 100, the minimum radius, so it's not gonna be able to find the small circles in the image. And what about the Hough gradient alt? Let's see that. And it's different. Let's copy this and comment this. If I'm using alt, you cannot use the same parameters. It's gonna be in some way crash. So it's finding nothing because in Hough gradient alt, this parameter should be different. As we said, the parameter 2 in that should be from 0 to 1. It needs to be. So it's suggested in documentation also. In most cases, 0.9 should be fine. So let's start with 0.9. And let's see result. It's not gonna draw even it finds 3 circles, but it's drawing 1 because our for loop. So the differences between gradient and gradient alt it's not gonna give you, as you remember from below, it has 14 circle if detected, 14 column it will have, so we need to check each column. But in the alt part, it's gonna give you row, the number of circles in will be in the row side like this. This is our output, so each of them in different row. So this is the x-axis, y-axis, and this is the radius. So what we should do, just make it rows and change the I to 0, 0 to I. And now it will be able to draw 3 circles is detected. If you decrease it to 10, it's gonna detect all of the circles inside the image. What if I'm changing this again? It's gonna give you many wrong results, I believe. Didn't give. It means this is more accurate, maybe, I don't know. Still giving 14. 50, that's correct. Okay, maybe it's really accurate. Let's make 0.01. Still same. What about if I make 1? It's gonna detect 0. Okay. At least we see the alt one more, or maybe accurate than this one. Also my favorite one, the alt one, by the way. Let's leave 0.9 and minimum distance we already talked, 50. If you increase that, what happens? Let's say 150. It's not gonna be able to detect all of them. They didn't detect this one, most probably because this is close to this one, or this is close to this one, smaller than 150 pixels. So you can also define that parameter. Let's back to normal. And let's try different images. First of all, this one maybe, b.png. b.png. Let's try with the same parameters. As you can see, it's not able to detect all of the circles. So what we should do, maybe we can first of all decreasing the minimum distance. Let's make 10. So I believe it increased, but still it's not able to detect these. Let's make this 1, and let's decrease this 5. Before how many finding? 20. Let's see now. Okay, now it's able to find many, so let's make it 8 maybe. Okay, still many. Okay, so what else we can do? The minimum radius. Maybe this is not really able to detect, but let's see the other one, the other method we are trying. Let's back. Okay, let's open that and try this directly. Sorry, this is b.png. Okay, now let's define. This is 1. This is 10. Okay, let's try. It's wrongly detecting. Let's increase the threshold. Okay, what else we can do? Increasing this also to 100. Increase this to 100. Why it's not able to detect? Let's think it. Maybe make it 70. Okay, make it 60. It's still really not able to detect all of them. This one was more better, I believe. Let's back to that again. And with this maybe we can try again. 1, 10. Let's change again, sorry. I, and I. Lastly rows. Okay, let's continue with gradient alt. Yeah, this is better, I think. It's almost able to find all of even the half ones. Maybe little need to increase this one. Yeah, I believe it's able to find mostly all of them. This is better, as I suggested. Then let's try the most difficult one, this one, e.jpg. And let's see the result. It takes time. Also, this image is maybe a little bigger. Yeah, it's detecting also many noisy. The minimum distance maybe we need to increase to 50 again. Okay, now in this case also it's able to find. These are, I think, difficult cases. This is a real world example, but it's still able to find most of the circles. You shouldn't expect to find these are, because these are not circles. Even in the real world they are circles. In the image it sees like ellipse. These are looks like ellipse, so it's not circle for the computer. And so this is also not an artificial intelligence model, so this is just analyzing the contour, so it cannot find this as a circle. It's an ellipse for him. And what else? This is also accurate, but if we try again, let's back quickly, sorry, let's last time to be able to show other one, this one, the e.jpg. Let's try with other method. Okay, because of this, still because of this one, let's decrease to 100, still 150. Yeah, but I believe even you try some of that, the second one will be the better one. Just I wanted to show you how it looks like. Even you little play, maybe you can able to get others, but this is the robust one comparing to this one, so I suggest you this one. Also, I have a video, circle detection video in my YouTube. There is a simple logic, a simple algorithm I'm using in there. You can also check that video. And I'm done for this video. See you in the next videos.